All right, this is APAB Calculus, and we are at the end of the year, so we are officially doing Intro to BC. That's right, ITBC. The first of the ITBC topics is parts. So we're going to start with integration by parts today. So let's start with the formula, right? And then I'll show you where it came from. So the formula for integrating by parts is you integrate u dv, and it ends up being uv minus the integral of v du. So what's important here when you're doing this is to notice that you're looking at a product where, so the big hint is that you have some product where u sub won't work. Okay, and we're going to walk through some examples. We'll walk through some examples that you have in your packet, and I can also walk through some extra examples to help you out with it. But so the issue is you're looking at some product where u sub won't work, and this is how you integrate it. Now let's, before we go into doing these problems, let's actually talk about where this formula comes from, because it comes from something you know from APAB. So recall that in APAB, when we were learning to derive things, we learned that if we learned the product rule, right, to take a derivative, right? So when we were learning how to differentiate a product, we used the product rule. So if I wanted to find the derivative of some uv, right, where there's a product of u and v, two different things, it's u dv plus v du. Cool. So let's say I wanted to go the other direction and I wanted to integrate, right? So if I wanted to integrate this thing back, right, if I wanted to integrate the derivative of uv, I'd have to integrate the other side, which would be u dv plus the integral of v du. Great. But the integral of a derivative, right, the derivative of the whole thing would just cancel, and I would get uv equals the integral of u dv plus v du, right, both integrals. Now, if you notice, this is that exact same formula, just solved for a different thing. If I leave the u dv by itself and I subtract the v du over, right? So if we go up here for a sec, if I say, hey, I'm going to make this uv minus the integral of v du, that's going to equal the integral of u dv. And that is parts. So parts is fundamentally doing the product rule backwards, right? It's a clever way to integrate things that cannot easily be integrated using something like u sub, or cannot possibly be integrated using u sub, but really it's just the product rule backwards. So that's where it comes from. So let's walk through example 1 in the packet. Gives you a problem that is parts and a problem that is not parts to sort of show you the difference. And I'm going to walk you through those, even though they're in the packet, and I walk through them in the packet. We all know that I make a million typos. So let's walk through example 1. So in example 1, I give you one that's parts and one that's not parts. We have x e to the x squared dx, right? And the other one I give you is the integral of x e to the x dx. So here's the thing. One of these is parts, and one of them is good old-fashioned u sub. Even in BC Calc, your default assumption should be, hey, let me just check if it's u sub, right? Because if it's u sub, it's so much easier, and there are still u sub problems that are going to happen in BC. So we should do a quick check and say, hey, if I made the inside function, which in this case is the x squared, if I made that my u, which would be an x squared, then my du would be a 2x dx, and sure enough, a multiple of that appears in the rest of the integrand. That's what makes this u sub. So if you're the person who needs to solve by dividing by the 2x, that's fine. If instead you could look at this and just realize it nets you a 1/2, that's also fine. But you're going to end up getting x e to the u du over a 2x. The x's cancel, so you end up getting that this is a 1/2 e to the u du inside your integrand. When you integrate e to the stuff, you get e to the stuff, so your answer is going to be a 1/2 e to the u, which is x squared, plus c. So simple u sub AB topic. It's okay if you feel rusty at that, right? It's after the AP. We're all allowed to be a little bit rusty at our skills. But A was simple u sub. Now B is not going to be simple u sub, right? B is going to be parts. So here's the hints that I can't use B as u sub. Hint number 1. Usually we try to make our u the thing inside another function. Well, the only other function here is an e to the x, and the thing inside the e to the stuff is just an x. Making u equal to x is really not something that's ever useful, because if you called u x, then you would basically replace every single x here with a u, and you'd be in the exact same situation. You would have made the problem look different, but not better, right? And our goal in u sub is to make the problem look like a common antiderivative that we know. So instead, right, I'm going to try using parts. So when we talk about doing parts, it really all boils down to the big first step, which is that we choose u, right? We choose our u by an acronym that we call LIAT. okay, which I didn't invent, but at some point someone on the internet said it, and it totally works, so it's what I stand by. So L is for log, right? I is for inverse trig. A is for algebraic, so like an x squared or a square root of x. T is for trig, and E is for exponential. And in that order, that's how you choose your U. So when I look at this, I see I have an algebraic expression x, and I have an exponential expression e to the x, so my U must be the algebraic expression, right? And my remaining stuff is going to be my dv. So what's going to happen when I do parts is I'm going to set up a nice little grid where I write that u is x and dv is e to the x dx. Right? I'm then going to derive to find du, because I know that that's something I need in my formula, right? And I'm going to integrate to get v. Now keep in mind I'm not going to write my plus c. We're going to do that when we're all done. So recall the way the parts formula works is if you're integrating u dv, which were these two things, I get uv minus the integral of v du. And this is the thing you're definitely going to want to memorize. This comes up a lot, right? It's a big deal in BC because it's one of only a handful of new topics. So I know that my integral is going to be uv, so it's, I personally like to do, I write them in this exact format, and then I do u times v, right? And then I subtract the integral of v du, which is the bottom two. So the only one you never use is the dv. So the integral of v du, which is an e to the x dx, well, you'll notice that what's left here is something that I can integrate really easily, right? I can integrate that e to the x really easily. I still haven't written the plus c because I know that plus c is going to go into, all the plus c's from all the different integrands are going to go into the very last one. So I integrate e to the x and I still get e to the x, and now that I'm out of integrals, I write my plus c. And that c represents all the individual constants I would have gotten through however many integrals that I would have integrated. So again, classic U sub, integration by parts.